Good morning, everyone.
Morning, Greg.
Thanks very much for joining this session. It's the OGC Future Directions session, which we hold at every TC meeting. We have a special session, special Future Directions session planned for you today. But first, I will just give you an overview of what the Future Direction session are all about. So the session aims to provide OGC members with exposure to ripe and near-ripe technologies that have been identified by the OGC Technology Trends activity, as well as other initiatives within the OGC. And those technologies are discussed with the OAD and effectively used as the basis for planning for Future Directions sessions. The sessions are held quarterly, so every TC meeting, and generally the format involves a panel of presenters with about 15-minute presentation per speaker, followed by a question and answer session, including discussion. So the process typically involves reviewing the OGC technology trends mind map, discussing options with the OGC architecture board, and then selecting options in terms of ripe and near-ripe technologies that could be explored by the Future Directions session. And then we invite speakers to present on those on the selected topic. However, for this special topic, sorry, for this special session, what we've endeavored to do is to provide you with an overview of OGC Testbed 14. But it's important to keep in mind that at the basis of all that we do in terms of technology forecasting, the OGC Technology Trends activity plays a key part within that process. And what you can see on the slide right now is the Technology Trends mind map, which we use to help organize some of our thinking. So over the past year, we've covered a variety of topics. You'll recall at the December 2017 TC meeting, the focus was on modeling, simulation, and prediction. Then at the March 2018 TC meeting, we focused on autonomy. Then after that, the next TC was on cloud-native computing. And most recently, the session focused on unmanned systems, not just UAVs, but also covering unmanned ground vehicles, as well as unmanned underwater vehicles as well. For today's session, the focus is going to be on OGC Testbed 14 outcomes and their implications for the standards program, as well as the OGC Technical Committee as a whole. And we'll have Luis Bermudez, the Executive Director for the Innovation Program, presenting those outcomes and guiding us through the discussion for the rest of the session. So without further delay, I'll ask Luis to take us through this topic. Thank you.
Good morning. Okay, you can hear me. So good morning, I'm Luis Bermudez, and it's my pleasure to
to be here today talking on behalf of the threat architects and the participants that did this great work in Testbed 14. So Ingo Simonis, who is the threat architect, was supposed to give this talk, but he's in Germany. Greg Builder, Scott Surridge, and myself. So first, a comparison how big is Testbed 14 compared to the previous other 3 testbeds. We see that about 103 organizations are participating. This includes observers. So about 74 organizations are being observing this initiative. And this is a reminder for all members that if you are an OGC member, you can observe other initiatives. We have an indoor pilot, smart cities project, etc., that you can always sign in to listen, to learn, and to provide better information for the participants if you have something to share. About 245 individuals, 52 components, and 23 documents that most of them are going to be presented at this TC for making a motion to make them for the TC to approve release to the public as a public document. And as you see, it's not the biggest testbed. The biggest testbed was Testbed 12, but it's still the second biggest of what we have done. And these testbeds, they are now following the same schedule every year. So right now we are in process of writing the call for participation based on the requirements of the sponsors. So hopefully we will have that by the end of December, and we will have the kickoff in March, April. So this is, or was the schedule of Testbed 14. As I said, it will be very similar to what Testbed 15 is. You see, the period of execution is very small, like from April to November, December. So we really do this very agile development, and we know how to do this. We had 11 sponsors. Thank you very much, because if we didn't have sponsors, we were not able to fund participants, and we're not able to advance some of the challenges that I'm going to present. So thank you, Atos, thank you, ESA, thank you, the STL, European Satellite Center, FAA, UNOVUM, Natural Resources Canada, Ordnance Survey, US Geological Survey, NASA, and NDA. Thank you very much for your support. And we have 31 participant organizations that did the work. You can see them here. And most of them are going to present at the different working groups this week. So in order to manage an activity like this big, and we have like 30 or more participants, and we have a lot of requirements, we usually divide the different topics in threads. So we had 4 threads in this testbed. First one, we call it Earth Observation Clouds, where from that activity we have 4 engineering reports and 14 components. These components are servers, clients, middleware, etc. We have one testbed called MOPOC, Modeling, Portrayal, and Quality of Service. From this one we had 10 engineering reports and 19 components. The next thread was Next Generation Services, and I'm going to walk through all of them. We had 7 engineering reports, 15 components, and the compliance side, we had 2 engineering reports and 4 components. So in total, we have about 25 engineering reports and 52 components in total. Let's start with the first one, Earth Observation Clouds. So NASA was a sponsor and was interested in increasing the usage of low-level satellite data, in particular level 1 and level 2, and defining what are the type of data and what standard interfaces we should we should use in order to increase the level of this type of data. So this will simplify the use of satellite data and maybe could encourage the development of higher level products, maybe through standards like web coverage services. Now the difficulty on this is that if we go to the OGC coverage model, and we go in particular to the version 1.1, it didn't allow for modeling of all the types of SWOT data in a very efficient way. So for example, the cells are not rectangular and they vary in size. And if you see the figure, the resulting SWOT data could have, for example, the shape of a vertical curtain. But here the cells are not rectangular, and in most cases they vary in size. And second, the traditional coverage implementation schema model separates the domain data and the range data. So this is, for example, the spatial temporal characteristics and the property of those values that are in each cell, and define some mapping rules. And this has proven to not be the most efficient way, optimal way to manage SWOT. So after the understanding that the current model does not really provide the support, and it's really increases even the value, the size of these files by a factor of 10 or 1,000 sometimes. So the participants analyzed the different SWOT types. So it was done a consultation with the NetCDF Conventions SWOT data editor. This is Alex Jelinek, to find a common approach. We explored the various options and eventually developed an OGC SWOT coverage model and 3 different standards in coding. The WCS profile was complemented by also a resource-oriented approach, following the guidelines of what other OGC working groups were doing. And lastly, we explored data visualization, data access patterns used for SWOT data. For visualization purposes, it was recommended to not only use low resolution, whereas data access should provide the full detail, including the exact cell locations. Now, the way forward, so there are various WC elements, SWOT profile, the resource-oriented version. Those needs to be incorporated into the WCS specification or develop a profile or best practice. Further on, turn out the SWOT data support is pretty limited in a lot of the current GIS tools, in particular complex data types such as those vertical curtains that I showed at the beginning. So we need to develop more of those clients and allow to increase those capabilities in current GIS clients. So once we have those tools that allow processing of those low level SWOT data, there are some mechanisms that I think should be explored that allow that republication of these new SWOT data into new WCSs, including maybe all the necessary, metadata to understand what the applied processing was. So am I going to, if there are any questions, I'm going to wait till the end, Kobe, or this is, at any time there are questions, people should?
Ideally, if you do the whole
presentation. So the next topic is Earth observation applications in the cloud. And right now we see that we have more and more applications that are cloud enabled. They're being deployed and executed close to where the data exists, and that's all the purpose of bringing applications to the cloud. In Testbed 13, we developed an architecture that allows an application developer to develop an application that contains all information to be run in a workflow. This is, for example, using Docker containers. So we created some metadata and all the necessary information, like what are the inputs, what are the parameters. The application package was registered in a WPS service, and then the consumers that were trying to get to access that WPS, then they were able to invoke it. In Testbed 14, what we did was, can we create workflows? And can we register not only one application, but a workflow that is composed of various applications that can live on different clouds. So in addition to moving from that local machine and having only one cloud, can we move to a more like distribution environment and have an execution plan. Also thinking into what are the costs related to that plan execution. So basically we have two major challenges. One is to describe these workflows as a sequence of applications and understand that each of these could be executed in a different cloud. And second, we also had, for the first time, I think, in any of OGC initiatives, talking about can we have information about, for example, a quotation or a billing model that allows commercialization of Earth observation apps. Right, so if you're going to run a workflow, then somehow you get information about how much is it going to cost. So initially, it was evaluated different workflows expressions, but it was decided to use this CWL, which is the common workflow language, versus BPL and BPMN, which are others. But this was defined because it was simpler, because it was less error prone. There are a lot of tools that also provide support for this kind of language if we want to execute those processes in Docker containers. And it also follows very closely to what the Docker execution commands provide. So it was sort of the best language, or at least the participants identified was the best language to use. In Testbed 14, the approach was to use OWS context, but this was dropped in favor of a pure WPS description. Let's see what else. So the application format, yes, was revised, so it was made more simpler than the work that was done in previous Testbed, and it was also developed a resource-oriented architecture for the WPS execution. And at the end also we had the model where we were able to provide them the information about quotation and billing when we want to run these workflows across different nodes. So the way forward is, I think it is important to develop an open API for WPS, maybe 3.0, so that's a consideration for the WPS working group. Use the language CWL and bring that to the workflow domain working group as a language that, maybe more best practices can be developed around it. There is also this model that was started for the quotation and billing model. Maybe this is something that can get more formalized within OGC. Maybe also in relation with the distributed ledgers work. And why not having a consolidation pilot, which I think is underway for 2019 to mature better the architecture and the work that was done in Testbed 14. So now I'm moving forward to the next topic, which is the modeling, portrayal, quality of service, or MOPAC. So first was the application schema modeling and conversion. And this is a task that has been done in, I think, the last 5-6 testbeds, where we're trying to see where we can get UML conceptual models. A lot of OGC standards are based on UML, and how we can provide a more readable, machine-friendly. This is sometimes, email application schemas, and sometimes OWL-based ontologies. So, so in particular, this task was to advance that last part, is how can we create ontologies based on the UML. And define an application profile that can be used, and maybe at the end we'll have what was done in this testbed, for example, to have linked data applications. Determination of preliminary techniques for the development also of subsets of ontologies to support different types of applications. Initial model for defining metadata about application profiles. This includes like definition of RDF application profiles, as I said, for linked data applications. And also there were some complex analytic linked data applications that can be supported with these, and increase the OGC community's understanding, for example, of the state of art of JSON schemas. Why? Because when we're using these linked data applications, we're using JSON for linked data. And JSON is very popular, so it's a way to provide a formal agreement of how to express data. And in this case, like a conceptual model for, or a schema to have the rules of how the data should be structured. So JSON for linked data technologies is applied to the encodings of ISO 1909 conformal unified modeling language applications. So, so this is a screenshot of the tool that is used. It's called Shape Change, and this is the Shape Change profile management tool, where it allows you to define different applications profiles. In this case, the application profile that was of interest is the NSG application schema. And you see in this case, well, there is a taxiway that is being defined with an aircraft movement surface inside this application schema. But the important thing is that if we have this UML or application schema, that there is a methodology for modeling that allows to create from this application schema linked data and ontologies, meaning developing RDF applications for profile or simple linked data applications, and also more complex linked data applications. The way to move forward, there is always a lot of ground to improve in these what we call UGS tools that start from UML, JSON schemas, and does some type of transformation, for example, to GML. And so we want to still continue to work on those challenges. Also, we want to advance the use of shackle as related to OCL constraints, which are different ways to encode rules, to be able to do this transformation from one model format to another, and improve conversion of OCL constraints to other rules, for example, schematron and OWL, and extend the use of shape change rewards to support better JSON schemas. The other topic was information registries and semantic enablement. The sponsor, FAA, has this system which is called NAS. It's the National Airspace System SWIM, System-Wide Information Management. And they have a service registry and repository. And we wanted to evaluate it. The problem is that the registry is an existing system that allows for the search and retrieval of metadata related to services. However, it is not very easy to search on what are the current services that are in the registry provide. So we cannot get details about feature types and what are the possible values that you can do like a more sophisticated query. Now, that was the requirement. So for example, I cannot currently find a service that provides a flight plan data in fixing that that's one of the encodings used in the aviation community. So how do we semantically enable the registry, allowing to use, read, find data in WFSs, for example, that provide the data in some profiles like AXM and fixed the aviation industry. So several methods were evaluated and discussed about how to better annotate the metadata in the services and the registry. One of them was the web annotation model that allows to provide a little bit more information on those services. So we use metadata level semantic enablement to support better the discovery of information of what was available in the registry. So before we have, for example, information about which service provider run with TrueBurn, and now it's easy to query like which services provides run with TrueBurn information from East Coast airports. So we were able to annotate better those registries so we can do more complicated queries, for example, including the geo and location of features. So the way forward is, one, the participants think that the web annotation model to be able to tag information is a good way to go to enable semantically those services. And also a way to move forward and more work is how do we link the work done with other technologies that are registry related like DCAT, GeoDCAT, Open Data, SRIM, and if in those registries can we use the same technology such as the web annotation from WPS. Another topic was LiDAR point cloud data handling. And there was a study that was conducted about the state of the industry for point clouds. And it was even followed up on a previous industry survey of the OGC point cloud that we're working through. And if you see the chart here, the question is, did you experience software interoperability challenge when working with point cloud data? And about 80% said yes. So there is most of the participants agree there is a challenge with this type of data. So the approach was first, identify requirements for use, storage, and transmission of cloud data. And these requirements, they investigated what were the mandatory and optional requirements, and then using those requirements that were found to evaluate 5 of the current industry solutions. And each one were evaluated using some consistent criteria and other market research. And the Point Cloud Domain Working Group is starting to evaluate the results of this study and hopefully should recommend how OGC and the industry should move forward related to LiDAR point cloud. So the 5 current packages that were investigated are listed here: IS3, CellPK, Tree Converter, Greyhound, and one 3D tiles. Now, one also big point about this study is to help spatial data infrastructure to make their own decisions about how to deal with point cloud data. So the way to move forward is the web service specification that are coming from OGC should or may follow the additional requirements to be considered. So a static tiling approach that can be aligned with the work that has been done with WPS and package. That the work should be suitable for archive data storage, a lot of big data storage, and transmission to recall progressive access over HTTP network protocols, and also downstream application performance sensitive to data organization. Those are the 3 main recommendations to move forward, thinking forward. The next topic was machine learning, deep learning, and artificial intelligence. This is the first time that this topic comes into a testbed, so we're very excited about it. And the question at the beginning was very open. So how is geospatial data integrated with these type of systems? Meaning, the input for machine learning and artificial intelligence can be, for example, imagery, vector data, and data streams that hopefully maybe use OGC standards, but also the output, maybe they can be provided via OGC interfaces. So the question was really very, very general. And we expect to advance or derive best practices that will enable folks that are running these systems about how to integrate OGC systems into the work. So this task showed how OGC services and the special resources were integrated into these machine learning systems. We look at what APIs were involved, in particular OGC WFS, web feature services, and web cover services, to define like image repositories and feature stores that when this knowledge base wanted to get a particular feature, then it will go to this repository and get the information, so then the machine learning was able to process that information. The machine learning was run with OGC WPS, web processing service, but the key part here was this build knowledge base that allows to link with the needs of the machine learning and the information about where the data and how to access, where the data reside and how to access that data. The way forward, so this image shows, what was this? This was some, you see some yellow areas that cross classification of images, and for example, it shows classification of parks according to it was a land use classifier. And there are a lot of suggestions related to future work. For example, we need to have something maybe called the Special Machine Learning Systems Best Practice, also artificial intelligence for Earth observation applications packaging that allows to provide queries on these Earth observations packages with a little bit of AI, workflows and best practices to be able to run geo data with machine learning, and also why not machine learning for disasters interoperability, which is more domain focused. Another topic was MapML. This is also a recurrent topic in our testbeds, and the basic idea about this work is, can we make maps truly accessible default by any browser? So we can imagine an HTML tag that a lot of browser supports that we can add easily a map. And there is a lot of work that is being done. So currently we have a pure HTML. Map is not a tag that is supported. So we had to develop plugins or libraries that are needed to be installed by the user to be able to read something like maps.r tag with MapML. So there was developed something called a server worker. There was a proxy for MapML that was using the server worker browser API. So the application takes a MapML document and it injects that into the web components library cell. And this gives an automatic support for MapML in browsers that are still not supporting MapML natively. And the second implementation was a cloud-based MapML, also service to proxy. cascade existing AWS content services that was able to bring data from WMSs, WFSs, and WMTSs, as well as other map ML documents. So remember that previously we had these AWS content services that allows you to provide information about any, I think, OGC service. So MapML is sort of reusing that to also include other OGC services, other resources into MapML, and then the web browser should be able to see the map and the data that comes from MapML. So the way forward is, well, for example, explore how we can include this next generation of OGC services, those rested like WFS3, into MapML, more easily potentially use of MapML for social media, and increase the functionality of MapML, full integration with OGC standard baseline, and hopefully the future generations of these standards, in particular for maps and patterns. Portrayal, there's still some work to do in Portrayal. There's always work to do in Portrayal. So the idea here is that even if we have some data and symbols, can we provide the same or maybe very similar portrayal in each user's computing environment? So a lot of OGC applications, they use what is called the OGC style layer descriptor. This is SLD, but it has not been updated, and there are a lot of challenges that right now we have trying to use SLD. So as part of the portrayal concept development study, it became clear that a new portrayal was necessary. So the question became, how do we develop a new portrayal model? So given that if we have some data and symbols, can we provide the same portrayal model to any user computing environment? So it's one conceptual model with multiple encodings that can be supported, so users can have these good environment and interaction with the data. So the idea was to start with something easier and then increase into a more sophisticated hardware model. So for example, we have trying to track my time. So we started with bridges and see and look at what is called the MIL standard 2525 that has a set of composite symbols, as well as other simpler things such as roads, boundaries, and other areas. And some encodings and environments that were evaluated were the SLD and CSS that is used in your server. Also, there is something called Car2SS that provides some styling to encode feature data, JSON encoding and Mapbox studio rendering, the WML with portrayal support using mapping, and your package with portrayal support. So all those environments were evaluated. So there was also previous encoding of the conceptual model in Gnosis, cartographic map style sheet, CMS format. So if you want to learn more, always the reports provide more information about the work done. So what was found was that, there is sort of a conceptual model that can bring all of these together. Of course, there is additional work to be done, both on the main conceptual model and also all the different individual encodings that will ensure there is future interoperability of reusing this conceptual model. Now, there are some things that were not part of the study, such as 3D, raster, and augmented reality. Those were not part of the study. So these might need to be included in future work. The next topic was quality of service and experience. And there was a discussion paper called Ensuring Quality of User Experience with OGC Mapping Services. This paper provides an assessment framework and identifies some issues about how do we measure quality of data that comes from OGC services. And it outlined all these criteria that is presented here about how to measure them and some recommendations. So the goal was to identify any challenges that needed to be discussed in the paper, and then try to see if we can do some work in the testbed to move forward some of the recommendations from the paper. So as you can see here, I think maybe that was too small. So things like legibility of explanatory text, or whether the map displays what title states, legibility of symbols and colors. All those were, for example, details of a quality of experience when looking at a map. Oops. So in the testbed, a graphical user interface was developed that helps to assess manually the criteria. There was also an automated service. JMeter was used to automate other criteria that was possible to be automated. There are some things that are not able to do in an automatic way, and JMeter is a very easy way to create those rules in the case that it's possible to automate that criterion. And we also look at, well, if we have these JET capabilities in a lot of OGC services, can we include some information such as the operating and performance that will allow to improve the quality of service? So there were some change requests that were provided to WMS and also to other services to have maybe better, to provide to the user a better human readable landing page experience. Some recommendations about way to move forward. So the assessment tool contains right now 3 basic components. It is WMS layer selector, metadata information viewer, and also the quality assessment panel. There are also linkages to these quantity reports and also performance using a tool used GeoHealth, and organizations such as, for example, the National Spatial Data Infrastructures can use these tools to assess and also to provide, to give feedback or to provide feedback to service providers regarding their service instances, allowing at the end to improve the quality of service and the experience to the end users. I'm going to jump now to the next slide. So good water break. So next generation OGC services and API. So we examine next generation OGC services from the perspective of complex 3D data, complex data schema, and these work hopefully lead into web API building blocks rather than the current monolithic service that we have. Maybe using the same API, we could address the different separate needs that we have in a lot of OGC services, for example, WFS and 3D portrayal service. So for the next generation of OGC services and API, the approach was to extend the service architecture that is currently using WFS 3.0 as a starting point, and then build API building blocks that will allow you to support more complex data, more complex queries, 3D portrayal. So there were like no general issues when the participant started using like WFS and then moved to 3D PS or WMTS or WMS capabilities to the next generation architecture. So it was proven that is fairly consistent. There was also some good experiences about removing redundancies in a lot of the different services when you try to put them, all together. So the approach for dealing with this complex feature handling, which was one of the issues, was, well, we wanted to have several use cases. For example, one was querying and filtering features and properties related to nested objects or expressions that we need to build on complex predicates, which is usually how do we find features inside other features. Querying feature data and returning, for example, only parts of the features, which means we're only returning parts and selected properties. Access to and query of solid geometries and other geometries, maybe using 3D coordinate reference systems, and also use of response for display in web browsers. So the way forward, there were some ideas for extending WFS 3.0 for improved fetching, migration of additional resource types, using current OGC services standard to a next generation architecture, which is great because it's going to be, this new architecture will provide some patterns, ideas for new services. Investigate how GraphQL could be used to query a feature data set. So it's something that to be done in the future. Consider the use of CT-JSON as an additional WFS 3.0 encoding for 3D CT models. I think this is the first time that I heard CT-JSON in some of the test beds. Develop guidance for implementing advanced search capabilities for WFS 3 APIs, which is a new standard, so right now advanced search is not supported. Next topic, federated clouds. So sharing data, compute resources in a dynamic, collaborative environment that can span from different administrative domains, leading to the concept of the federation sometimes can be challenging. Because of the different security approaches, for example, OpenID connected OAuth that can be used inside the federation. So the approach was, well, let's coordinate across all the federation related to Testbed 14 tasks, including the Earth observation clouds and workflows. We need to understand the role of federation design space and analyzing what are the capabilities of that federation. And there was also a liaison with NIST and IEEE, joint working group on federated clouds. So all these were taken into consideration. Now the primary result was that future work should identify and prototype the different types of specific use cases when access decisions are being made by outside administrative domains. because that's the main issue. We can have an administrative domain that have a set of queries and a security way to implementing that federation, but when there are some cases outside of that federation or that administrative domain, that's when this gets complicated. So the way to move forward is demonstrate how this federated identity can be consistently and managed use, how the scope of the attributes and authorizations can be used consistently and managed in different federated environments, and how resource and discovery and access can also be consistent managed across these different administrative domains. It will be very good to have what we call a federation deployment model that can be reused in different federations. And also, we need to develop an awareness and understanding of the purpose of having trust federations, that they have their own security model, and what are the rules that we can trust federations so that we can interact with them. Other topic, security. And security is also like a constant topic in testbeds and a lot of other innovation program activities. And the idea was to extend the work that was done related to federated identity management into a more detailed level. So we wanted to describe a more general approach that can be used in security architectures, use the current state-of-the-art standards that take into account the security standard candidates. We want to, the challenge was to include the best practices into an integrated security, into federated clouds and workflows, and also illustrate the implementation of what are the initial steps that folks, if they want to implement this, need to take to realize the practices that have been brought in this work. So the approach was, we'll take this initial step to complete all the security architecture, especially if we want to include them in special infrastructures. So a more general architecture than what was done before. It describes and hopefully provides a solution that can be used, covering all the details about workflow and federated cloud concerns, right? Where do you need the authorization servers? Where do you need the OpenID connect endpoints? If you need mediation servers, how do you connect different federations, different secure environments? And hopefully will enable future discussions of more complex security architectures and how to access details that are needed to implement those security environments, such as credentials, for example. So if we have this architecture, can this approach be reused in more complex scenarios? But I think this is a very simple, clear architecture that can be reused. So way to move forward, well, we have that architecture, but we want to explore in the future more fine-grained authorization mechanisms, client credentials, our resource, owner grants for workflows, and also using something called JSON Web Tokens to efficiently store and sign and encrypt user information. But we want to also look forward into how to use OpenAPI, since it's become very popular in a lot of the new REST services and capabilities documents, to maybe automate the way we do the token acquisition, and to develop a federated manager that is capable of allowing to manage these different resources on the manager owner side to facilitate the resolution of the different governance issues that can be part of federated clouds. Secure workflows, also related to the other topics. So the challenge was that there is the need to dynamically add custom workflow processing functionality to servers that are available and that are growing. There is a WPS somewhere on a server, and can we allow some dynamic upload of workflows so we inform the server that there is a new process. BPMN in this case will use business process modeling notation, I think something like that is called. An ISO standard address many of the issues and alternatives. In Testbed 13, it was described some rudimentary implementation of this BPMN engine to exclude remotely some authorized documents, but there was no like best practices for orchestration. So the work that was done in Testbed 14 was building on this Testbed 13 to examine a transactional approach for the web processing service WPS 2.0. So this is what you see, WPS-T. That included key value pair, KVP, and XML bindings, and also an abstract test suite, and a process deployment profile using the work that was done in the previous test, but using BPMN to allow these dynamically update of processes. And also, if these provided best practices to enable the orchestration of OGC services, and a helper class was also developed that allow the implementation, how to interact with the different processes, and to be able to create, to run the workflow. So JBPM workflow. So this slide shows the equation of some messages that go across the different service components. So there is here a client D143 that executes, called a WPSP, that then interacts with an execution unit after trying to find the whatever service is available in the catalog, and this execution unit was also supported by this called BPMN engine. So the way forward is hopefully the development of profiles for WPST and a REST binding, and in the future we would like to see that the orchestration is able to show, for example, likelihood that the workflow has been completed to success, and the way also to how to manage BPMN to WPS, process transformation, have more sophisticated encoding options, and also a way to remove of access on more complex use cases to take advantage of, for example, if you want to run it in parallel, some decision gates that will allow you to run the workflow in a more efficient manner, and compensation events. Another work that was done, CT, HTML, and augmented reality. So the challenge was, well, we wanted to have a high detail, fully integrated view of these urban spaces, required hopefully for planning and execution of CT managers, example we call modern urban missions, and we want to be able to evaluate the use of augmented reality technologies into CTTML content and develop site support for visualization of CTTML and AR. So there were various prototypes that were studied in the testbed. There were also some performance constraints that we encouraged related to real-time camera view augmentation using 3D virtual objects derived from a CTTML dataset and anchored based on GPAs or whatever the device can provide. So the work included some prototyping on the architectural elements such as the service interfaces, the data that is available on the back, a component of how do we provide binary 3D data for an efficient transmission format, building a client AR that also supports, for example, CTTML. So the images show very early prototypes that are able to bring CTTML data and augmented reality. That was on the left. On the right, you will see like a more better image. But there were very good advances in this regard. So the way to move forward, so the scenario of augmented real-time device location and camera views with heavy precision located 3D virtual objects creates a substantial performance burden. So it's very hard, and I think most of the participants here are more on the geo side, not on the AR side. So we need a lot to learn on that side. There was not a very defined use case. We had just this broad idea about, well, we think AR is good, let's bring CTTML and AR, but having more very concrete use cases that help us advance these two technologies will be very important. Requirement that might allow for a high capacity workstation client with 3D assets preloaded, or for pre-planned rather than emergency response scenario is also important. So how much do we need to preload an application with some of the data that is available to have a better experience for the user? Good, then the last topic was compliance. The challenge about profiles adoption is, well, as we know, profiles with extensions, as we call it now, is a standard plus some restrictions, rules, plus other stuff, rules. In the case of the testbed, we wanted to have an executable test suite for the DigiWeek Catalog 2.0. So, for example, there were some things that are part of the profile, such as verify that the response indicates support for English, for parables and returnables, or verify that the XML response indicates support for CSW record and DMD MD metadata. So these are concrete rules that the DigiWeek says we need to test for these, even if some cases this is an option in the real standard. And also, the idea to have an executable test suites and implementations is that, well, we can verify other implementations and we can encourage implementations. Since the test is available, there's an implementations that other folks can look into and learn, then it is easier to have implementations. So the approach, we developed the DigiWeek Catalog service for the Web 2.0. We developed something that is called an executable test suite that is based on the annex of the standard is called abstract test suite. We also provided feedback to the draft standard, and we advanced a reference implementation, which is GeoNetwork. And a byproduct also is that the GeoNetwork was fixed also to become a reference implementation for Catalog 2.0. So this is also a great byproduct of what happened in the testbed. Now, a way to move forward, and I put here, I think, one of the most hot topics the PC discussed mailing list, that is, well, we require multiple implementations when we are moving a standard and we approve it. And I would say that a way to move forward is, if we can, as much as possible, to parallelize the work of developing the standard and at some point develop some of the executable test suites and also develop some of the early implementations. Of course, we need a little bit of developing the executable test suites at the beginning, or I don't know exactly, but parallelizing these three will be great. It's the way forward. Good. Another challenge that we have in the compliance project was testing resource-oriented services. And well, OGC is and will be developing more REST APIs. There are no REST tests that existed before Testbed 14. And now that I think this over, yes, we have an initial test that is based on Sensor Things API, but it was not developed in a way that we're doing it right now, that we're thinking more about how to support other REST APIs. There are some issues like we don't have any more capabilities documents, so where do we start? And also there are the issues of there is a resource that you can navigate to other resources, and this can create infinite loops when you're trying to test. Even when you're developing an implementation, you can have, even when you are developing an implementation, you can have those issues. And in some cases, there is no XML, so you have DML application schemas. So you want me to move these? Nobody told me about it.
The orange arrow, white arrow on the orange button.
Yeah, I know that, but I have a question. I cannot see it from here, so it's very hard. So looking at that screen, that makes the trick. Yeah, they need to only look at that screen. And also in some cases, there's no more XML, so it's JSON. So how is JSON schema playing a role here? No, I lost my mouse. So we developed one of the first tests for resource-oriented that can be used in other OGC APIs. This is the WFS frequency executable test suite. And one of the things we did is we used OpenAPI as a starting point. And I know there is a discussion about, will this be a performance class? Is this part of the core? Please fix that issue. Picked one of the output format to test the responses. And I think the working group needs to be sometimes a little bit, let's say, aggressive on making a decision about, we need to make something good defaults for others to easily implement. And not saying, yes, we allow everything, because it's really hard, in particular, to make the test. But we use JSON. And also, we need to make sure that the test is configured properly to select some features, or if there is, coverages, for example, WCS, that we're not testing all of them because the test time will take a lot of time. So the approach was selecting, having a good way to select some features and that we can repeat the process to allow testing of features in a WFS frequency here. Now for new tests that are following REST, the way forward is create an OpenAPI conformance class or make it part of the core. Core must be the simplest minimum good to have rules, please. And mandate that default encoding, maybe GeoJSON or other. Now, we also have work done on testing secure clients. In the past, we had a WMS 1.3 test, but we needed a better architecture, in particular with the web validation tools, and we want to add a security component. We have two use cases. One is to verify that the secure client can anonymously connect to the secure server using HTTPS and issue valid request. And second, use case similar to case one, but we want the secure client to provide authentication to the server. And this is part of all the great work done by the security domain working group. So we developed, a client was developed based on ArcGIS, and also we developed a test client that is able to support secure services that come from WMS 1.11, WMS 1.30, and AWS Common. Why? Because they provide different, get capabilities approaches. So the secure standard provides different way to tag the get capabilities, telling what is the secure protocol that is supported by the server. But here you see the main workflow architecture of what we did. We have a client, connects to Team Engine, which is this web validation tool that OGC provides to validate the tests. Then we need an identity provider. Then we go to the service, for example, WMS, provide this information to the client. Then the Team Engine also needs to have this information about the identity provider that can validate the client, and then the client is able to maybe, if you understand the capabilities of the server and it has the proper identity, be able to connect with the server. Team Engine provides this proxy that between the client and the server to be able to intercept the request and check that the requests are done properly. So for new tests, consider adding performance classes for client testing. There are very few standards that take this into consideration. One of them was WMS 1.3 that has a conformance class for clients. You will say, well, but it's really the same. No, we really want to have like a performance class that specify some of the real rules and things that we want to test for clients. And second, consider reusing the client security conformance class in future tests. I'm going to talk a little bit about Testbed 15. We have some topics. We are in the process of writing the call for participation. So we are planning to have machine learning. How do we provide different models and integrate them, the vectorization of data to use in machine learning, and maybe a use case in the Arctic. We're going to have a data-centric security services. This is, well, maybe how does security on the future level work in OGC. So we have addressed some of the service-based security in the past, but the next step, I think, is to add this security at the future level, maybe using something like XML. Delta updates. This is particular use in DDIL, denied ready intermittent and low bandwidth environments. Data exchange still is a challenge in this environment. So this task will look into what are the priorities to be more efficient moving the data and maybe reduce some of the data traffic to the minimum. So to support these environments. Discovery of Earth observation profiles, so continue advancing that task, and link data. We want to advance the semantic web link builder and also create some triple generator that are based on that those link data. Also work on the DigiWiki metadata foundation. Right now, there is not a compliance test for the DigiWiki metadata, so maybe we can advance some of the tasks related to developing the test. CDP and grid is basically asking the question of how 3D geospatial databases support, for example, doing training and mission rehearsal, where CDP data is being used based, for example, on existing grid systems. Federated clouds used, we want to explore the NIST and IEEE and the work that are doing on the federated cloud architecture, and also based on the work done on Testbed 14. And cloud analytics with Scale and Seed. We did an engineering study with some of the work that NGA has advanced related to cloud. So we wanted to advance this as basically a platform that is able to run a lot of, hundreds of different processes in defense systems. This is the schedule of Testbed 15. Right now we are in the process of running the call for participation. We have identified sponsors, last minute sponsor, maybe welcome, but I think will be hard at this point. But we already have the sponsors and we already have those requirements that were listed, and more details will be published. The plan for the call for participation publishing is December 21st. The plan for the responses are due on February 3rd, so you don't need to spend the holidays, working the response. We have the beginning of the next year to work on that, and the kickoff workshop, I think it's planned around April. And again, we're planning to finish by December of next year. So thank you. I provided links here to Testbed 14, where we're expecting to link to the other reports. And I invite you to go to the domain working groups, where a lot of this work is going to be highlighted in more depth. It's very difficult to do this in an hour. So the reports, and there are a lot of participants around here where you can get more information. And I really want to thank all the sponsors, participants, for all of the great work that we do in these Testbeds. Thank you very much.
So we now have time for questions. Are there any questions from the floor?
Wow, I can't believe I was so clear.
Okay.
So all I can say is just a comment is that I'd certainly like to know more details. I would just like to know more details about what's being planned for Testbed 15, but I guess those will be coming out soon.
So, Luis, it seems like in different parts there were a couple of workflow engines being used. I know, and there's been a kind of one of the ERs has been put out there up on the BPMN, which is always hard for me to say, but and then it seems like there was maybe another thread where something else was used earlier in the presentation that was used and said something like, that it was working better or something in certain cases. I'm just curious I wish I could remember what it was, but.
Yeah, CW something, and I remember
Yeah.
that, and I also have that good question. And I think that's maybe the good topic of discussion for the workflow domain working group. About, let me comment. Here, CWS.
I didn't know, I don't think I've seen any paper yet about the other one, and so the common workflow language there. So I was just curious if I've missed that one or not, but I'm just curious I'll be, want to hear more about that comparison or something at some point. So.
2 minutes.
Hey, Lisa, can you flip to the symbology portrayal slide? The comment was make the symbology, there we go. Make the symbology as similar as possible on these different devices. I guess I would challenge that assertion. I mean, yeah, people need to be able to do that. But the real challenge here is to make the symbology appropriate for different devices. You've got a device like this, standard 2525 Charlie's not going to be readable. The challenge is actually to know what the symbology, what it is that you're symbolizing, and then what the appropriate different types of symbology are for different platforms, and have the appropriate symbology for a platform come up. one of the areas of research in cartography at this point is what is appropriate symbology for a small device like this with a tactile interface that's used in all kinds of different environments. It's not throw 24,000 flat sheet symbology on a cell phone.
Right?
Yeah, I agree. I guess that's kind of generic in one sense, but we agree with you. But I think, I was looking for Sarah, she's not here right now, but she's the author of that. And I think she would agree with you as well. And that wasn't the actual intent, but the intent was as similar as possible based upon, the rules that we were working on. And it's not based upon, knowing that a geo package is going to be on a handheld. They are going to look at things different than if you've got a huge monitor and stuff like that.
But maybe the idea is to have one conceptual model that allows to capture the rules
Yeah.
of what is the best way to have a symbology here. What is the best way to have a symbology in this environment? Not to have same symbols, but maybe a common model of expressing those rules.
I guess the other challenge that I would throw out there is once you move beyond the, how do you define general portrayal and that sort of thing. Here in the U.S. and in Europe and the European Union, we have ADA requirements, disability requirements, and access to information for disabled users, be it visual, color line, tactile issues, things like that. Those are challenges that need to be taken up in the symbology and symbology portrayal as well. What's appropriate symbology for a tactile challenged individual or whatever. And as a community, if we don't address those issues, we'll find ourselves on the wrong side of growing numbers of lawsuits over, at least in the U.S., there would be ADA violations.
Yeah.
Louis, can I chip in there? Just Chris Little. I just want to follow up from Keith's remarks, which I agree with, and I agree with what Greg said as well. And that's why I put a paper on pending. I've made 2 versions now, saying we're starting in the wrong place. A lot of the new environments and a lot of the activity inside OGC is in the 3D world, 3D, CDGML, indoor, drones, and actually starting in 2D and making the 3D an extension of it isn't going to work. And I'm advocating we use computer graphics as the basic model for 3D, and then 2D falls out of it by projection. And at the same time, there's an awful lot of work gone into computer graphics to make things accessible. All the work in the 3D, W3C, area committees. So if we use kind of start from where computer graphics is rather than where we were with cartography in 2 dimensions over the last 100 years, I think we'll get a better conceptual model. So, but I think there's a big debate around that to be had.
Very good.
Anyone else? So while you're walking up, I just think we ought to have a portrayal DWG, just another one.
So, I was going to say, some of the testbed participants are in the room as well. So if there's any point that you'd like to, maybe highlight or add to, feel free to just raise up your hand and I'll bring a microphone.
Thank you. Out of the testbed 14, could it be possible to the software developer be installed in one premises for demonstration purposes? Besides the engineering report, it's quite an important result, but you do the engineering report, normally develop software, you do things, so it would be possible somehow to have a demonstration or some place where to see these things running. I'm talking about the machine learning, I'm quite interested in the work done there. So in order to sponsor the next initiative, it would be nice to have really some physical use cases, not only engineering report.
So I think we have some information with the participants agreement that says that.
Well, they'll keep their Yeah, all the participants are required to keep their services up and available for the next year. So, but it's not going to be in one spot where you're going to get to it. So yeah, it will be accessible based upon the agreements that they've made. But we're not going to have a demonstration like we have in the past where everybody comes together and shows stuff.
And they should be
Although-
available.
Although the EOC thread is doing a demonstration in January. You knew that, so.
For the machine learning, do you think we're going to have?
They are available. I don't have the endpoints and
Yeah,
stuff like that. but yeah.
they are available. The endpoints are on the wiki, on the Testbed 14 wiki. And if you go, if you go on there, you can find something you're looking for. Just feel free to send us an email, and we can point you in the right direction. Okay. Any other questions or comments? Okay. There's one other thing that basically falls out of one of the slides, particularly with regard to next generation OGC services. It's a point that was actually made during one of the sessions yesterday, but I think it's appropriate for sharing in this session as well. So it was a point made that within Testbed 14, the pattern that has been used for WFS 3.0 has also been applied to WPS, WCS, WMTS, I believe, as well. And so we're seeing that pattern being successfully applied to a variety of services. And that gives confidence that that approach is repeatable and can form the basis of future OGC web services. So I point that out because that's something that's an observation that has been supported by the results from Testbed 14. And I don't know if there are any views or comments on that next generation OGC web services approach. It's a hot topic right now, so I don't know if there are if there's anything further that perhaps the participants would like to share. Okay. No, nothing. Oh, what's that ahead?
Yeah.
I was looking in your direction.
Yeah, I saw that. So yeah, I mean, obviously I would support that, and I think a lot of work was actually done, so it's worth reading some of the engineering words from that thread. And I think some of the recommendations have broader implications, and I think that's one of the things. So for example, some of the recommendations are specific suites, like the WFS suite, and we need to discuss it there, but some of the things have a wider implication, like how we deal with media rights and several other things that I think where we need to find the right forum to have these kind of discussions. That's just what I wanted to add there.
Okay. Any comments?
I'd just be curious when you surveyed threat architects, and based on feedback from working group interactions so far, what aspects of Testbed 14 seem to be getting the most traction in the working groups now? What are you observing? Next gen?
I think all of them. All of them.
Okay. If there are no further questions or comments, I think we can probably draw the session to a close. The signing in box is ready. It's outside. It's blue, I believe.
So sign out, don't sign in.
Sorry, yeah, sign out. Don't on your way. But yeah, thanks very much for your participation this morning. I think it's been a very informative session. Thanks very much, Luis, for that great presentation. And yeah, I look forward to seeing you in the other sessions this week. Thank you.